Hello participants of micro irrigation engineering subject. Now we are starting lecture 39. Lecture 39 we will discuss about bubbler irrigation. In the family of micro irrigation emission devices, we discussed various type of emission devices, where drippers we discuss online, inline, point source, line source. Then we discussed in previous class on micro sprinklers. Now, this is the another type of micro irrigation emission device, which is known as a bubbler irrigation system. So, this in this particular lecture we will discuss about the what is the importance of bubbler irrigation system, how does it work, and what are its components and its layout, and what are the points which should be considered while designing a bubbler irrigation system. Bubbler irrigation is a localized low pressure solid state permanent installation system used in trees. The application rate generally exceeds the infiltration capacity of the soil. Therefore, bubbler irrigation system is more relevant to basin or furrow methods of irrigation, are needed to control the water distribution on the land. So, either we form a basin or we form a furrows. Water infiltrates into the soil and wets the root zone. So, here overland flow takes place, and then it goes slowly through the infiltration process, and then as in other case, here the gravity component, gravity flow component in the porous medium is more as compared to the other kind of a system in case of micro sprinkler you have seen, or in case of the drip irrigation we have seen. Although the bubbler application is extensively used in landscape irrigation system, and its use in agriculture is limited, because we are talking of reducing the water supply. So, we want to minimize the losses. So, it is likely that it may wait more than the desired root zone depth. So, when water supply is not a constraint, that is one part, and then another one is that the quality of water from the debris or the sand, silt which is flowing with the water, that causes the clogging problem. From that point of view, this is more important. So, in those situations it is very good, and one should go for bubbler irrigation. Now, two types of bubbler irrigation systems are used. One is a low head or gravity and or pressurized system. So, low head or gravity system, when we say, this is limited to 10 kilopascal pressure, whereas pressurized we say this is this goes up to 150 kilopascal. Bubbler systems are well suited for perennial crops and like orchards, vines, because irrigation system typically include buried pipeline, and small earthen basins are made around the particular plant, and bubbler system can also be adapted to row crops that utilizes the furrow. So, furrows are constructed to take water from the bubbler to means guide the water. The bubblers are small plastic head emitters. This is what you see, these are the small plastic head emitters, and with threaded joints, means here it is a threaded joint. So, it can be connected with the there is another plastic stem which is also threaded. So, they were originally designed to use on risers above the ground for flood irrigation or of small or ornamental areas. But now these are being used. Initially they were used for such purpose, but now these are used for irrigating fruit crops. They perform well under wide range of pressure, delivering water in the form of a fountain. This is what it looks like it in the form of fountain or small streams or tiny umbrella. This is the way you see here in the vicinity of the emitter. Emitter is this particular device. So, this particular device, the way this water is coming out, this particular emission, this type of emission of water is known as a bubbler emitters. They operate, that is 1 to 3 bars, and then the discharge rate is 100 to 200 liter per hour. It can be further, these are available at higher discharge, and filtration is not required. This is the another beauty, that filter part is eliminated in case of bubbler system. Potential advantage, that compared with other micro irrigation system, bubbler system had some potential advantage. It requires low energy, maintenance is low, susceptibility to the emitter clogging is low, water with higher suspended solid concentration can also be used, the operating cost is low, interval between irrigation are long, and duration of because amount of water or flow rate is large. So, irrigation interval is short, irrigation event is short, accumulated salts are uniformly leached, bubbler basin increase the catchment of rainfall. There are some disadvantages or limitation, we can say. Very few agricultural bubbler system have been installed or in operation. As I told you that it requires more water, and then basic purpose or the main advantage of having micro irrigation system is a last when we talk of the giving water through bubbler. Design criteria and recommended operating procedures are not well documented. This is the another thing, and then entrapment of air in the pipeline network can lead to the blockage. And then farm topography need to be leveled. This is the another important thing, that otherwise water will not guide to the so because there is overland flow takes place. Bubblers are not suitable for sandy soil, correct, and then small earthen basins are typically required around the plant, so that the water can be guided in a proper way. Cultural practices are more difficult to perform around the earthen basin, because we are flooding the whole field, we are giving the water in larger point. So, it is likely there will be more weed problem. So, that becomes more difficult to perform around the plant. Now, let us come to the system layout and components. The bubbler system layout is typical one of all the pressurized irrigation system. However, some basic difference exist relating to operating pressure and flow rates. It consists of simple head control unit without filters and fertilizer application apparatus. So, fertigation it is not done by using the bubbler system, because the fertilizer which we will give it, the dissolved fertilizer it will not only be available into the plant, but it will be flowing as overland flow to other place. The mains and sub mains are usually buried PVC pipe hydrants rising on surface. The manifolds and laterals are also often buried rigid PVC pipes. The bubblers are placed above the ground, supported on a stake and connected to the lateral with a small flexible tube rising on the surface, or they can be fitted on a small dia PVC risers that is connected to the buried laterals. The difference between bubbler system and other micro irrigation installation system is that in other installation the lateral lines are of 12 to 32 millimeter. That is the maximum, in case of micro sprinkler 32 millimeter it can be, and normally we use 10 millimeter, 12 millimeter, 16 millimeter pipeline for drip irrigation. Whereas in the bubbler system laterals are usually of 50 millimeter in diameter, because it is delivering higher discharge. So, discharge rate is high. So, the laterals are 50 millimeter size, and then these pipelines are laid below the ground level. The another category of bubbler is gravity flow bubblers. The gravity flow bubblers are unique in that they are not designed to dissipate energy, unlike these associated with other types of micro irrigation. Bubbler emitters are essentially delivery tubes for transferring the water from irrigation laterals to the plants. The gravity bubbler system operate at very low pressure, that is about 10 kilopascal, where the flow rates through the delivery tubes can be altered by adjusting their outlet elevations, because the operating head of the bubbler is low, that is about 1 meter head. Small changes in the elevation throughout the system have large impact on discharge rates. Additionally, frictional losses within the pipe and tube affect the water pressure within the system. Therefore, they affect the discharge rate, because here again the discharge is a function of the operating pressure, and pressure it gets affected because of the frictional losses. There are some connectors, so they affect the discharge rate. For a small diameter smooth pipe, the Darcy-Weisbach-Blasius equation has been combined to predict the frictional head loss in bubbler tube, that has been given by Keller and Blissner in 1990. The equation given by them is given that head loss due to friction in the bubbler pipeline system is given by Kf into Kf dW. This is a constant, this is the unit constant multiplied by the discharge in the tube in liter per second, divided to the power 1.75, and then the diameter of the inside diameter of the pipeline to the power 4.75, where the diameter is expressed in millimeter, and L refers to the multiplied by the length. So, L refers to the length of the tube, which is expressed in meter. So, one can find out the head loss in this pipe when Darcy-Weisbach equation and Blasius equation have been combined in this part. Now, one can find out how much head loss it takes place when these are the discharge rate, and then head loss has been estimated for the different size of the pipeline, for the different size of the internal diameter of the pipeline. So, let us say that it is the diameter of the pipeline, it is increasing. You can see 4 millimeter, 6 millimeter, it is increasing in this direction, and this is the bound where the Reynolds number is expressed. So, Reynolds number is that is 1 is to this 10 is to 6 to the 40 into 6, 40 to the power 6, that is your the 1 lakh to 4 lakh, that is the value. So, head loss one can find out. Suppose we have been given the flow rate of 1 liter per second, the diameter of the pipeline is 104 millimeter, and then one has to see that what is the Reynolds number, and corresponding to the Reynolds number, the values of Reynolds number one has to choose, and then take the value, one can get the value of head loss gradient or head loss, that is expressed in, that is meter by meter. So, this particular factor one can get from this. Pressurized bubbler system. The pressurized bubbler systems are similar in design to alternative micro irrigation system, and typically operate between 50 kilopascal to 150 kilopascal. The emission device, however, have relatively high discharge rate, that is up to 225 liter per hour. The length of a small diameter emission tube control the rates and in a manner similar to that of capillary tube in drip irrigation system. Uniformity can be achieved by adjusting the length of the tube. This is important, that is because as you have the more length, more coiling length if you are doing, so more will be the head loss, and that will disturb the uniformity. So, one has to see that part. Discharge rate as a function of tube length, it is a function of tube length and can be derived from the fundamental principle of energy conservation within the bubbler tube, can be derived from the Bernoulli equation, where you see the pressure head, elevation head, velocity head at section 1, means at the upstream section of the tube, where the pressure head it is given by the P1. So, this is at the location 1, and then this is equal to the pressure head plus elevation head plus velocity head plus sum of all the frictional losses plus sum of all the minor losses. So, minor losses is due to connection, all the connectors, elbows, joints, that takes care about the minor losses, and this is as I told you that we need to calculate the head loss due to friction by using the appropriate equations, which already I have discussed in previous class by using Hagen-Williams, by Darcy-Weisbach or Scobie formula. Scobie formula is normally not used in pipes with made up of plastics. So, this you can calculate. Now, these components one can, means these already I have explained you. So, this is for the second location or means downstream location in the pipeline. When we apply Bernoulli equation, bubbler tube point 1 and 2 can be set at the entry and outlet of the tube. There are several assumptions that has been made to simplify this equation. These assumptions are that minor losses are 0, no elevation when it is placed in the same elevation, and continuity equation applies, means V 1 equal to V 2, and then the P2 equal to 0, that is means the water which is coming out, this is at the atmospheric pressure. So, P2 equal to 0. So, finally, this equation results in this form. So, discharge of a bubbler tube can be given by, this is a unit constant, that is a Kb multiplied by P over Lb. P is the operating pressure, Lb is the length of bubbler tube multiplied by the diameter to the power 2.71. So, this is a unit constant when we are using we are getting discharge in liter per hour, and P we are expressing, that is the operating pressure in kilopascal, then length we are expressing in centimeter, diameter we are expressing in millimeter. So, if we are putting all these things, we need to put the Kb equal to 5.52 to get the value of discharge from the bubbler tube. Now, one can find out the what is the bubbler discharge by using this nomograph. So, this nomograph has been developed when the diameter is ranging from the 1 millimeter to 10 millimeter, and then operating pressure is at 10 kilopascal, and length it is varying from 10 centimeter to 5 meter. So, this is the range which has been estimated, and you can see if I take any value and then we see what is the diameter. Let us say that my diameter of my length of the tube is 2 meter, that is a 200 centimeter, and then diameter is this. So, I will be using, say, diameter is 10 millimeter, then corresponding discharge I can get that what is the diameter discharge. So, I will get the discharge, it is about, we are getting about 500 liter per hour. So, like this directly one can find out without calculation by using this type of. The another one is, if we are interested to find out what should be the required length, then if it is a required length of 2 millimeter, and then the 3 meter tubing for the desired discharge rate in liter per hour according to the inlet pressure. So, I can find out what should be the required desired discharge rate. So, if this is one case, this is when the diameter is taken as a 2 millimeter, and then if I want to get the what should be the discharge from this particular tube. So, given a pressure, and then selecting a particular length, I can know that what will be the discharge of the particular this bubbler system. So, in this particular, in these two things, when the two diameter the pipelines are available, and then given the bubbler tube length, and then one can know what is the for a given pressure what will be the required discharge, or for an assumed discharge and the length of the tube, one can find out what will be the operating pressure. So, that one can get better uniformity of application. Irrigation scheduling: with bubbler irrigation, percentage of root soil volume weighted is about 80%, because here water given is in more in quantity, large in quantity. So, weighting root zone weighting is more. So, it is about 80%, and there is no restriction, restrictions on the way of scheduling the program, means it can be pre-programmed. So, no restriction on the way irrigation program is prepared. This can be either fixed depletion or fixed interval, means either we are fixing the depletion level, that we need to have the depletion level of 80%, 70%. So, depending on the so irrigation schedule can be made, or someone wants to make the interval that every 5 days I need to give irrigation. This is also possible. So, take into consideration the soil water holding capacity, that is a field capacity of the soil, and the availability of irrigation water and size of the flow. Then the design criteria and consideration, the bubbler irrigation is mainly applied to fruit tree orchards, and the most important criteria apart from routine design criteria are the system's special feature and characteristics. Bubbler emitter discharge water on the same spot of ground as at high rates. Thus, for a uniform distribution over basin area, minimum of land preparation is required. Mature tree always take 2 bubbler emitters on each side in order to ensure acceptable uniformity of water application, because in case of mature trees the water requirement is high. I think the bubbler irrigation is appropriate in that case, and the 2 bubblers will take care of the meeting the water requirement of these such trees. The common practice is to have 1 lateral per 2 rows of the trees with a small flexible tube extended on both the sides and connected to the bubbler. That is the normal common practice, but in order to see that when the plants are old and then the rooting systems are deep, and they were being given the conventional irrigation. So, the root systems are deep, and then it has got large with the root zone depth. So, in that case this kind of a practice, that 2 bubblers are used. In this way, same size of the lateral pipe placed buried, that is it is kept below the ground level between 2 rows can serve the 12 trees each side. So, which is spaced 6 meter interval with 48 bubblers system bubbler emitters. So, if we are putting it for the 12 trees and then 2 laterals are kept. So, we will be 2 the deeper surface, there are 24 trees in total, and that is at the 6 meter interval. So, we need 24 into 2, that is a 48 number of bubbler will be required. The size of the equipment for the installation should always be able to accommodate the flows required for the maturity. This one should take care. For longer laterals, pressure compensated bubblers can also be used, with which involves higher energy consumption, more expensive and higher pressure drop. So, this is a typical bubbler laying system, where you can see this is a laid in a 1.15 hectare area. So, this is 120 meter long and 96 meter wide, and these are the trees, where you see this is a tree, and in between the tree this is the lateral line which is passing, and then on each lateral pipeline the bubblers are attached, and this bubbler will be giving there will be appropriate number of bubblers depending on the requirement, maybe 2 bubblers or 1 bubbler to each tree, that can be taken care depending on after knowing the water distribution. So, here you can see here there is a the water source. From the water source the water is brought with the help of pump, and then pump is then there is a main pipeline, and then from main pipeline there is a sub main manifold, and from the sub main manifold these laterals are attached. These laterals goes along the plant rows. So, you may refer these books for this topic, and then let us summarize this lecture. We have discussed about the bubbler irrigation system. We also discussed the 2 types of bubbler system. One is gravity flow type of bubbler, or pressure flow type of bubbler. We made the comparative advantages and disadvantages of this system. We also discussed about the irrigation scheduling, and then what are the important design consideration one should take care. In the forthcoming class, we will discuss about sprinkler irrigation system, and thank you very much